So, if you were here, we were graphing reciprocals. We talked about the little big, what do we call it?
The little big principle.
Little big principle. Yeah. The reciprocal is a fraction, or you flip the fraction basically. So basically, like, what's the reciprocal of 3?
1/3.
1/3. What's the reciprocal of 1,000?
1,000.
1,000. The little big principle says if your starting number is really little, like 1/1,000, the reciprocal will be really big. And if your starting number is already really big, like 1,000,000, the reciprocal will be
1/1,000,000.
really small.
Oh yeah, the big, small.
Yeah. And so then when graphing these, we were looking at the graph of the original and then graphing the reciprocal based on that idea. So here's the one we were working on. If you want the whole explanation,
Oh yeah, we never finished it.
go to my channel, like and subscribe. You'll get the full 30-minute version of that, basically.
But even then, I feel like it's still confusing.
So here's the brief version. We're trying to graph this. We know how to graph the original. Well, some people do. Still don't know how to do that. Well, then you got other videos to watch even more. So anyway, if we can graph the like the reciprocal of that, flip it over, graph x to the third minus x squared plus 1. Oh, that's easy. I know I have to factor it. So boom, I factor, grouping. Oh, boom, I factor. Oh, I factor some more. Hey, and I come up with x plus 1 times x minus 1 squared.
Okay.
Well, so then we know the x-intercepts are -1 and +1.
And we know they're in behavior.
If we plug in 0 for x, we get the y-intercept, which is +1. We know end behavior is x to the third, so it's down on the left, up on the right, and we can come up with this.
Boom.
That was your last quiz. Problem 1, 2, 3.
Yeah.
Right?
Didn't know how to do that.
Okay. Hopefully now you do. So now, maybe I'll, on this quiz, I'll give you credit, like, because you'll have to graph the original first, so I can go back and count that for your crap quiz. That's
Yeah?
I'm
done. I'm done.
Maybe I'll be a nice guy like that.
Please be nice.
But,
tomorrow, right?
Yeah. Do you like chocolate?
Or your red Halloween. What's your flavor here?
So now that we have this, we can graph the reciprocal. Basically, if we had all of the points along this curve, it'd be really easy.
But we don't.
Because we could just take all of the y values and flip them, and the x's aren't going to change, and then just put them on here, right? So what we do then is we start with the y values that we know, the points we know for sure. Like over here, we knew 0, 1. If I plug in 0 for x, I get 1 for y. The y-intercept is 1.
Because the reciprocal 1 is...
Okay, well, I wasn't even there. So then going to the reciprocal, what is the reciprocal of 1?
1.
Still 1, right? If I flip 1, I still get 1. So the y-intercept on my reciprocal is still going to be 1.
Yeah.
So if it's not 1, you do...
If it was...
do 1 over...
I'll do another example, but yeah, if it was like, here's your original, if it was like...
Like 2 would be 1 half.
If it was 0, 5, when you went to graph the reciprocal, your y-intercept would be?
1/5.
1/5, yep.
Right there.
Okay. It's so tiny.
I'm gonna run this whole chart for you.
Because if the original is 5, the reciprocal, you flip it, it'd be 1/5.
I'm not gonna run that chart thing.
So I do the same thing with my other points. I know my x-intercept is 1, 0, so that's a point I know. I know my other x-intercept is -1, 0. Those are points I know. If I do the reciprocal of these, like what's the reciprocal of 0?
Over -1. Nothing. Doesn't exist.
Size.
It's an asymptote.
1 over 0. Oh, so it doesn't exist there.
Wait,
It doesn't exist
Would it
there.
be -1 over 0?
It doesn't matter.
Yeah, it doesn't matter.
Well, it wouldn't be negative. I don't know why it would be negative.
Oh.
Reciprocal, you just flip it.
We're doing the y, not the x.
Yeah, the x's we don't touch. The x's will stay the same.
Okay.
Therefore, when x is -1 in the reciprocal, there's nothing there. Well, there's an asymptote there. I shouldn't say there's nothing there. It's an asymptote.
But
When
there would
x
be
is
no...
+1, there's an asymptote.
Will that be like it for every x-intercept in all the graphs?
Yes,
So there cannot be a asymptote on the y-axis?
there can be.
There can be?
If you,
Oh, horizontal one.
no, there can be a vertical. Like y equals x times x plus 1. If that's your original, your x,
Oh, I see.
your x-intercepts would be what?
Zero, one.
-1
And the origin.
and 0, right? So now if you did the reciprocal and you did graph 1 over x times x plus
Oh,
1.
the
Shh, wait.
middle thing.
If it helps you make a table, you can. X, y, -1, 0, and 0, 0. My x's aren't going to change. I'm still going to use -1 and 0. But now, when I flip these, what happens? Can't 1 over 0. 1 divided by 0, you can't do that. So there's asymptote right on the y-axis and 1 right there. -1. How do we check for horizontals? I know the calculus way to check them. Reciprocal way?
Also, all the x-intercepts become asymptotes?
Yes.
X-intercepts become asymptotes. Asymptotes become x-intercepts also.
Yeah.
They flip-flop.
I'm sorry.
Let's worry about horizontals later. I don't think...
Slants too long.
Oh, I know how you tell. I got it. Okay, you'll see.
Okay.
Here we go.
Okay.
So now that we have this, we're going to use the whole little big idea.
The little big.
The little big principle. Yeah.
Little bit.
Okay, whatever. Let's start. You notice we have like 3 regions here to graph.
Yes.
Yeah.
You should know something's going to go in each one of those regions.
Yeah.
Which one would you like to start with?
The middle.
The left, yeah.
The easiest one.
From left to right? No, we're in America. We read
Or
this way.
0.
So, you just go like this. This is the thinking part.
Yeah.
On the original, if I start at -1 and move to the left, my y values are going to start off really, really small, aren't they?
Really small negatively.
Really small negatively, yes. Like 0.00001, 0.0002. Is my pen moving? 0.0003,
Negative.
0.004. Oh, then but they're really small, huh?
Yes.
So it's awfully big.
So then if you flip those,
It's awfully big.
it's really, really big and negative. So that tells me when I go just to the left of this asymptote, this thing's going to go whoosh, really, really, really big and negative.
That's not big, that's little.
No, but it's getting huge.
It's big negative.
Like -1,000 is way down there.
Like this point right here would be -1.01, comma, 0.00001. I don't know, I'm just making that up. So on this one, it would be -1.01, comma, and if I do 1 over 0.00, oh, this is negative too.
10,000.
It's -10. It's big and negative. Right?
Yes.
The negatives mess you up, huh? It's okay. Just ignore them. Just keep it on the same side. These will never change signs. If it's negative here, it's going to be negative always over here. If it's always positive up here in the middle, it's going to be always positive up here in the middle in this one. And if this one's always... This thing's never going to be negative over here because this one never was. It doesn't change sign. Just because you flip something, the sign doesn't change.
Whatever section in the graph it is in, it will stay in that section, like the 4 sections of it.
Well, like on the right, it's in the positive, so it will always be in the positive on the right side.
Yeah, to the right of here, it's always positive. It'll always be positive on this one.
Where's the new
Hold on.
x-intercept?
Go, Galen.
With the little big rule though, like, so on the right section, it's not really big and it's not really small. So
On what?
What?
on the right section, I don't.
Over here?
Yeah. How,
Hold on, we'll get there.
Oh.
We're not even done with this one.
Suppose it's gonna
I
work.
know right here, this is a really little, so my flip it, I'm going to have really big. But then as I proceed and move along this,
It gets bigger.
these become really big and negative, don't they?
Should be
So what's going to happen to the flip?
Really small.
They're going to get really small.
As you
and
go
negative.
away from -1.
So this is just going to approach the x-axis and go along like a horizontal asymptote, Henry. So as these approach positive or negative infinity, these will approach 0. So that's how you find your asymptote.
So will it always be on just the axis?
No. Well,
Because your asymptote can move up and
I don't like to answer these always questions because then
Like, because you can move the origin of like the graph that you're making,
that's true.
so then it might.
I'm not going to answer your question.
I played the fifth, Your Honor.
Move on. As long as you understand the concept of like how to graph it, then it should just happen for itself. So we go here in the middle. Let's go to the right of -1.
The asymptote.
Start small, gets
As I go to the right, my originals are really, really small. So what are my
Let's start
reciprocals?
with the
big.
right.
Really, really big. It's gonna start way up at infinity and start making its way down. As this gets bigger and bigger and bigger, this gets smaller and smaller and smaller, right?
So it's gonna
Until this gets bigger and bigger and bigger, but it only hits 1.
and then it stops.
So this is just gonna get smaller and smaller and smaller until it hits 1. And these are all curves. Remember, these are sketches. These aren't perfect. Now, this is getting smaller and smaller and smaller again.
So big.
So this one's getting smaller and
So
smaller
it's
and
gonna be
smaller.
that parabola
This
case.
one's gonna get bigger and
Yeah,
bigger and
the
bigger.
weird looking parabola.
Yeah.
Yeah.
Because it's not like a perfect parabola, it's weird.
And the other one.
We just need a moment of silence.
Processing.
People are.
Processing.
I see this going on in the crowd.
I might actually pass this.
Okay, now to the right of 1. We're starting really, really small. So where will this one start?
Really
Really
big.
big.
I'm
And then
positive.
this gets really big, so this will get
Really small.
really small. So it's just gonna go.
It makes sense.
Looks so much weirder from the original.
Yeah.
Mm-hmm.
Can I give us like a
And
really?
now let's make sure. Let's check out. Because remember, I just learned this on Friday myself.
Henry being in his head.
What did he say? Can you give us the test?
No, he
No,
said,
give
give us
us
a
a
really
really,
hard
really
one.
hard one now.
Hey,
I don't know that that exists.
Feed my brain.
shit, he sent me a Snapchat.
Ooh, I should graph them both on the same axes. Let's see if our graph looks accurate. Yes.
Accurate.
It does it all crappy. I'd have to zoom in a little bit to make it.
Your window's a little big.
Yeah. There we go.
There we go.
There we go. That's it.
Why do you want to do this on a calculator that you spend?
Oh, click right.
I'll just make sure no calculators happen on this.
Make sure that
Like no graphing calculator or no calculation?
Hey, how do you do that graphing? I was trying to do that one last time. Y equals?
I didn't know you guys didn't know that.
Like, I got the Y equals part, and I had no idea what to do from there.
One more example.
Is it a little bit bigger than the other?
Bigger. We can
Like, more difficult?
I'll
No?
try to find a difficult.
No, I don't want to check it out, I just want to turn the AC on a little bit.
Oh, it's already cool.
No, air conditioning isn't like turning up the heat a little bit. Condition the air to make it.
That one seems hard.
The logic makes no sense.
Yeah,
You guys-
AC, and then
You
it's
guys say AC is cold. Air conditioning does the hot and the cold. It makes the air more hot.
conditioner only does cold.
Yeah.
Yeah.
See, this conditioner is to make it cooler.
Anyway, let's go back to math.
Hey, I'm glad to see you finally put some air in your towel. I saw that.
That, finally, I did that the day you told me to.
No, the next day they were still low.
They were.
It was still sitting like this.
Okay, fine. Second day. The second day.
That was on Friday. I was like, he still didn't put an air in. I was almost gonna call your dad and be like, hey, did you know you're gonna have to buy a new set of
We
tires
did it
for your
Friday.
son's car? Otherwise,
We did it Friday.
oh, I saw it the first thing in the morning.
Oh.
Okay, there. That's what we're gonna try to graph.
Okay.
Okay.
So do the first one.
Yeah.
So what's the first step?
You saw you graphed the
Graph the original.
Graph the
Backwards.
original.
And
Like
I
graph
do that.
to graph the
Like-
original. We shouldn't say original, I guess, but you graph the reciprocal, and then you can graph the reciprocal.
What? You graph the reciprocal of the reciprocal.
Graph the function, not
So the original.
So the
Graph
original.
the
Graph
original,
that,
and then graph
then
the
you-
We're gonna graph the
reciprocal.
yeah. We're gonna go like.
You
If
flip the graph.
We're gonna graph the normal looking one.
I flip that over, it's x squared minus 1 times x squared plus 1. But then
Is it
it's still negative, yeah.
Yeah.
Because
It
if you
changes
put
the
it, if
direction.
you divide by -1,
Just flips the.
you're still
It
putting
switches
the,
to ends.
yeah, but it's gonna switch it.
Okay.
So let's graph that.
Well, we can factor.
Now let's factor.
X plus 1,
X plus 1, X minus 1.
Same thing.
Uh-oh.
Oh, wait, no, you can't factor it.
You do like.
It's okay, I think we'll be okay. I don't know exactly. That's not factorable.
You just had to figure it on.
But it also doesn't produce an x-intercept.
So we're boned.
So we might be okay. Might have to
Is it an imaginary one?
we can check the graphic calculator just to make ourselves feel better about life. X-intercepts. 1 and -1. Yes.
Well, you can't.
-1.
You can't factor the x squared plus 1. Why not?
No. What would it factor to?
X.
Where's the
Plus one
negative
plus-
north?
Times x plus 1. X plus 1 times x plus 1 would be x squared plus 2x.
You can't do it positively.
Can't factor.
Difference of squares is.
Can't factor a binomial positive.
It's the difference of two squares, not the addition of two squares.
So there's our x-intercept. Our y-intercept would be -1 times -1 times 1.
So it's 1.
No, so it's negative.
No, it's not. Positive
Or
one.
it's one, it's one, it's one, one, one.
Don't you dare question me.
It's one negative.
So there's our. This is very similar to the last
How'd you
one.
do that?
Huh?
How'd you do that?
Do what? Y-intercept?
Yeah.
Plugged in 0 for x.
And then
0. It's negative in front. That one would just be 1. That one would give you -1. And that one would give you 1.
And you have the x.
So you like
Negative times
multiply
1 times
those?
-1 times -1 is 1.
Okay.
And you have the x intercepts by plus 1.
X-intercept, set each factor equal to 0, solve it, get -1 from here, get +1 from here. This one I don't get any x-intercepts from it, because if I set it equal to 0, it's x squared equals -1, square root it, and you get imaginary zeros, which are not going to go on my graph. We might graph imaginary crap later.
That's the
I don't know if we'll get that.
No, thank you.
It's fake news.
It's fake news.
So we're here and here.
graphs.
What's our end behavior now?
It's gonna be
Third.
flipped.
No,
It's to the fourth.
it's third.
X to the 4th, which would be
Oh.
up and up, but it's going to be flipped, so it's going to be down and down.
Why?
End behavior. Imagine it was.
So I believe we
It's
just
like
have
upside down
something
It's gonna look like that.
like that.
Sure.
So
Yeah, you
Because it's x squared.
find out the end
Wait, why
behavior.
parabola?
You multiply it.
Isn't that
X squared times x squared is x.
So
to the fourth.
4th, x squared times x squared is x to
It's
the
like a
4th.
parabola.
Oh.
So at the ends, it's gonna look like this, and then since it's
I
negative,
thought
it's
you
down.
had to do the W.
It doesn't have to do any whoop-de-woos necessarily. Doesn't have to.
Why?
It could, but we don't care. Yeah.
Will the imaginary roots change the line of it?
No.
No.
It won't change how it looks.
Wow.
It's a plateau.
Nice.
It flattens out right there, but no.
Is that because of the imaginary root?
Mm,
Graphed it on imaginary axes.
yeah,
Yeah. Okay.
but I don't think of it as like a solid rule of anything. It's just so basically we got an upside down parabola. Well, this one turned out to not be so hard. Coming back then, let's graph this sucker.
Yeah.
I'm gonna pick on people who are not here Friday and question.
That's not nice.
That's arrogant though.
Let's just
Okay.
go right on the list. All dare. All dare.
Yeah.
What do you know? Give me something you know about this graph.
You're gonna get the y-axis. The y-axis from the other graph and flip them.
So what is it gonna be? It's something.
So it's gonna be, what is it? 1 and 0 and 1.
Yep, it's gonna stay the same, right?
Yeah.
1 over 1 is just 1. So my y-intercept didn't change.
And then it'll be -1 and
I knew you. I was like,
Do not answer questions.
I could tell. I was just looking at her. She was like, you don't, you didn't.
Okay, what do you flip?
Same all the time?
No.
Well, though 1, my y-intercept is 1. So if I flip that, it's still 1.
How is it still 1?
Because
1 over 1
1 over 1 is still 1.
See, I'm not the only
can't make that
one.
smaller or bigger, just 1.
Oh, you're okay. Never mind.
The reciprocal of 1 is 1.
Because I was looking at 0 and 1. And I was like, you flip those and you get.
No. Okay, so these, what's going to happen with these? Gold, if you're here Friday, you came in. Fernando, you know? Asymptotes. Because 1 comma 0, if I flip 0, I get 1 over 0, which is not possible. So I'm going to have asymptotes. So this one does look similar to the last one. Yeah, this is really close to the last one.
No, it is the last one.
Dude, this is basically, except for this, well, look at
The only
Yes.
difference is that flat line.
Look at this one is whoops, and then this one went up. This one is just it keeps going down.
Wait,
So,
is that a math term?
this region and this region are going to be the exact same thing.
Great.
Got it done already? I think that's it.
So this will become.
Start as you move to the left. Start little, so start big. Go big, so go small. Just make sure you remember which way you're moving. Here now I'm going to move left to right. So it's going to start, this starts small, so this one will start big. Get smaller until it hits 1. Then this gets smaller, so this one will get bigger. So it's going to be that parabola thing right there again.
The weird parabola thingy.
It actually.
And then from here, it's going to be negative. This starts small, so this is going to start really big and negative. This gets really big and negative, so this is going to get really small and negative.
Hey, look, it's almost the exact same one.
What happened to the imaginary numbers though? You said
Nothing good. Like,
They don't, nothing. We don't really have to even worry about them.
Oh.
We don't have an imaginary axis. We're not graphing polar. We're not graphing imaginaries. They don't produce any x
What does polar even mean in that?
polar coordinates.
Yeah.
It's a circle. It's a circle and they go.
They're really
That's the joke.
didn't have the joke.
Yeah. What about polar bonds?
They're also cold. Just cold.
Here we go.
Black hole?
Redemption.
Black holes really? I don't know. Black hole?
Black holes.
Black hole?
What about the?
For you folks at home, is it on there?
Is anything real? Because
Yeah, you can see it. It's hard to see it though.
trees are not real.
Yeah. Oh. I was getting too close to all Darius. Kind of didn't want to start creeping him out. Oh yeah, that's smart.
Freeze it, not pause.
Second time you guys got it.
Look at it. That's your homework.
Anyone got a pen or pencil for
Hey, look, they can just pause their screen.
For a beggar?
Beggar.
Why you pick that up?
Golf people do this at home. You have been warned.
Golfers.
Anna didn't get one.
Okay, I did it. We just did that. That was you guys are do a hard one. I thought number 9 was gonna be hard, so we've already done that one.
Cross it off.
Cross it off.
Number 10.
I was gonna cross more off, but I feel like these are pretty quick.
10's easy.
I feel like you could knock them out in a matter of minutes. The only thing you may not know how to do is the 2. How do you deal with the 2? So yeah, when you so if you're trying to graph 2 over x times x minus 1, when you go to graph the reciprocal, it would be x times x minus 1 over 2,
Like a double reciprocal.
or 1/2 times x minus 1.
It's like a double reciprocal.
Why does that matter? Good question. Well, because it's going to change your, not on this one. This one it's not really going to do anything. It's a bad example. But let's say it was this one, 2 over x minus 1 times x minus 3. So then your reciprocal one that you're going to graph, x minus 1 times x minus 3. If you forgot about the 2, just graph that. Your y-intercept would be 3, right? However, you need that 1/2 in there, so then you know the y-intercept, which is 0.5.
Did you grab that?
What?
It's not 0.5.
It's 1.5.
1.5.
You said what?
Yeah, that's why I was confused.
9.
You sure? We go to the replay.
But that's about it?
That's about it, yeah.
Like what the